All right, I am remaining your friend, exactly Vincent Ikechukwu, EPSU mathematician. All right, so here we go by teaching you sequences and series. Singular sequence, plural sequences, series remains the same. So let me start from the concept of set. The set we taught you, set or set per se. These are the examples of the sets. These are sets. The sets A, set B, set C, set D are equal sets. So we now say that A is equal to B is equal to C is equal to D. The sets are equal. Why are they equal? Every element here could be found inside here. The same thing with this and the same thing with this. So that is why we say the sets are equal. The set is said to be equal to the fellow sets if all the elements in the set is equal to the element in the other set. That is what we mean by equality of sets. Now, based on these concepts, I want to place a little bit digression from this, then I'll come back to this. And what is the digression? The digression is this. Order. This order is just letting you know that the difference between equality and inequality. When A is equal to B, good. But when A is not equal to B, you have to answer the following questions. Is it less than? Is it less than or equal to? Is it greater than? Is it greater than or equal to? This is when there is inequality. The inequality poses the following questions to you. Less than or equal to, greater than or equal to. Now, I bring up a question to you. What is the question? 2 is less than or equal to 2. Is it correct? Is it correct? 3, 1 is less than or equal to 3. Is this correct? These are the questions we ask you. Because once you hear the word order in math, the first thing you should think is less than or equal to, greater than or equal to, which are from the thoughts that we generated from this, equality and inequality, not equal to. A is equal to B, we have been using that. But once we raise the question, A is not equal to B, we have to answer the following questions. Is it less than, is A less than B? That is to say, is A less than B, or is A less than or equal to B, or is A greater than B, or is A greater than or equal to B? These are the questions you need to answer whenever you say not equal to. So not equal to pose us to several questions. It is helpful even in programming language, whereby when you are writing a program, you may start from with algorithm by getting the box for it. You start with start, then you go down, then you go to diamond, whereby you have the decision box here, where the question will be, enter the number. You enter a number. If it rejects it, and here it is meant for you to enter a real number or enter a variable. Enter a variable could be A, B, C, D, but enter a number could be 1, 2, 3. So if you enter a variable while you are meant to enter a number, it will loop you back. If you enter the correct number, it will take you down. Such logical reasoning questions are extracted from this. It could mean this. If it is less than this, if it is not this, if it is meant to be this, it's supposed it's nearly this, approximately this. Such logical could be taken from the basis of this before you advance it. And that is the decision here. So that is under programming. Now, we pose to you some other questions. 2 less than or equal to 2. Is it correct? Yes, it is correct. Bear it in mind what we said. 2 less than or equal to 2. Here, 1 is less than or equal to 3. All of them are correct. Ask me how. Ask me how. Why are all of them are correct? All of them are correct. Pay attention. You are a male or a female. Is it correct? It is correct. Because I didn't say you are a male and a female. If I had said you are a male and a female, it is not correct. But if you say you are a male or a female, which means it is either you are a male or you are a female. The statement here goes by 2 is less than or equal to 2. That is to say, 2 is less than 2, or we say that the order, whenever you hear the word order, your mindset should go to this, 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 or this. So we have been working on equality. Now, not equal means inequality. A equal to B, we know. But A not equal to B bring to us on board at least minimum of 4 questions to answer. Is A less than B? Is A less than or equal to B? Is A greater than B? Is A greater than or equal to B? These are 4 questions arising from A not equal to B. And this may lead us in a topic that we call inequality, not equal. But we want to use this to lead you to some concepts. 2 less than or equal to 2. Is this correct? We said yes, it is correct. Because the statement says 2 is less than 2 or 2 is equal to 2. This is a statement. So 2 is less than 2 or 2 equal to 2. Which one are we taking out of this as a statement? We are saying the one that is correct is this. I never said 2 is less than 2 and 2 is equal to 2. I say 2 is less than 2 or 2 is equal to 2. You are a male or a female. It is correct. Because I didn't say you're a male and a female. Now, the next one is 1 is less than 3 or 1 is equal to 3. It is correct. 1 is less than or equal to 3. In a broader form, I can write it 1 is less than 3 or 1 is equal to 3. Explicitly, this is correct to this form, but in compact form of writing, I can write 1 is less than or equal to 3. It is correct because 1 cannot be less than 3 and also be equal to 3. So 1 is happening there. So 1 is strictly less than 3. We take this. Coming to this, 1 is less than 2. 2 is less than 3. 3 is less than 4. 4 is less than 5. 5 is greater than 4. 4 greater than 3. 3 greater than 2. 2 greater than 1. Actually, it follows in the same order. They are orderly arranged. I may prefer to put 1 is less than or equal to 2. 2 is less than or equal to 3. 3 is less than or equal to 4. 4 is less than or equal to 5. Still the same. You cannot place this order, this notation on this, because if you place 3 is greater than 1, you cannot maintain the same order, greater than for all. If you place this is this, You cannot maintain less than or equal to in all. So for that reason, we can easily say that this maintain orderly arrangement. So any sets that have this orderly arrangement maintain the same order. These are the sets we gather together and give it a special name, sequence. So a sequence is a set whose terms or elements are in orderly arrangement. This is a primary definition of a sequence anyway. We can proceed in giving more standard definition of a sequence by producing a formula that guide them. This is not a sequence, but it is a set. This is not a sequence, but it is a set. Yes, all the sets here are equal, but not all of them are sequences. Because of what? There's no orderly arrangement here, there's no orderly arrangement here, but all of them are equal under sets. So all sequences are sets, but not all sets are sequences. Where are we heading to? We are trying to let you know that the sets or the sequence, this, one can rewrite it as this, as a set of n minus 2, ranging from 1 and then stopping at 7. When n is 3, put 3 here, 3 minus 2, 1. Put 4, 4 minus 2, 2. Put 5, 5 minus 2, 4. Put 5, 5 minus 2, 3. Put 6, 6 minus 2, 4. Put 7, 7 minus 2, 5. You stop at 7. This is the meaning of this. So this is another way of writing this. This is the compact way of writing this. So instead of writing it this way, you can reduce it to this. And so this becomes a function of n. What am I saying in essence? If you can get a function that generates the numbers, even though they are not orderly arranged, it may be scattered this way, but you can get a function that can generate all these elements, then it is also a sequence. It becomes a modern definition. So I have been mixing up some terminologies. Members of a set are called elements of the set, but members of a sequence are called terms of the sequence. So members of a set are called elements of the set, but members of a sequence are called terms of the sequence. So now I will be using the word terms. So this is a term, this is a term, this is a term. So far, I am now denoting this as a sequence, not as a set. So instead of using elements, I'll be calling them what? Terms of the sequence. Okay.